Hello everyone, today I will be showing you how to do Trig-Sub in integration. So actually I'm not going to show you the whole process thing because it's very long. I'll only show you how to substitute it in, but then you have to integrate it by yourself later. So here we have three popular cases, but actually you can use Trig-Sub with a lot of things, even integral of x dx, so like this. You can use Trig-Sub with this. I actually made a video on that before. You can go check it out if you want. But here are the three popular cases for Trig-Sub. You can remember this. You can actually find pictures online of this. You don't have to use my handwriting. It's terrible. But yeah, in case you're wondering, dx, what is dx for each of them? Dx is just the derivative of each of these. So if you're using this and you want to substitute with trigonometry, and you want to substitute dx, you substitute with derivative of this, which is cosine theta. For this one, derivative of tan theta, and for this, derivative of secant theta. So yeah, remember this, and I'll show you an example. So the example that I'll show you is the popular and easy one, actually. It is area under the half a unit circle, which is this one. So now what do we do? Well, we want to substitute x with sine theta according to what I wrote earlier, and differentiate both sides. We have dx equals cosine theta and then d theta, and then we have an identity we have to remember. The identity is sine theta squared plus cosine theta squared equals 1 always. This is a trig identity. It's a really easy to remember one though. And because of this, we move it around, we actually get cosine theta equals to square root of 1 minus sine theta squared. And if you look at it carefully, this thing is exactly the same as this thing when x is equal to sine theta, which means if we replace x with sine theta and we put it in here, the whole thing is equal to cosine theta. And now we just have to substitute it in, so we have the integral of cosine theta squared and then d theta. And you have to just integrate this now. It's actually not that hard. Just remember a few identities and then throw it in, and then you're done. And then you actually have to substitute the sine theta back with x, and then use a couple more identities to simplify it and stuff like that. And then you get the final answer. Yeah, I'm not gonna work all that out for you because it's really long actually if I work out all the details for you. So let me just write the final answer. But yeah, this is the trigonometry substitution part. But then you'll have to integrate this by yourself with your trigonometry knowledge. So the final answer is actually right there, but I'll rewrite it for you. So inverse sine of x and then plus c. And here is the final answer. There you go. That is it for Trig-Sub. Yeah, you can use Trig-Sub with other cases other than these three. I even made a video about it, as I said earlier. You can check it out if you want.